start recording this because this is a really good. So you're thinking about comparing, essentially the percentage of students that go to college versus, and are you interested in maybe nationally or in Iowa, maybe comparing now versus a generation ago or 2 generations ago? What do you think?
I was like thinking like in the US and then in Iowa.
Yeah. So you could take like, kind of like the national percentage of students that pursue higher ed right after high school. And then you could look at Iowa and see what that rate is. So I'd say that's a very typical, good one to do. So pretty much you can take the United States rate or percentage as your null hypothesis. So let's say, I don't know, 75% go on to college right after high school or something. I don't know what it is. So you could say like P equals 0.75. And then your alternative is it different then? Now you may have an indication that it's higher or lower. So you might want to say P is greater than or P is less than or just different. You're not sure. Then you can find that rate for Iowa and compare it. And then the good and the bad of these kind of projects is, so for instance, there's thousands and thousands of high school students right in Iowa.
Yeah.
So your sample size is literally thousands, right? Many thousands. So any small practical difference, let's say it's 75 and let's say Iowa's 74%. Since there's so many, the sample size is so large, it may say it's statistically significant. Now, practically, it may not be that different, right? The difference between 75 and 74% doesn't seem like a huge difference. But statistically, it may come out as a humongous z-score difference. And so what I love to see on projects like that is, yep, we did the stats. It's statistically very significant. The probability that this difference would happen by random chance is really small. But practically, it's not that big a deal. I had a student last semester. She had a wonderful idea. She was testing the hypothesis of the proportion of voters for Trump that were white male. Was it disproportionately white male? So she looked it up. She looked up, okay, here's the percentage. Like it was like 38% of all voters are white male or something. And then the percentage of white male vote that went to Donald Trump was like 39% or 40%. So but statistically, that's it's millions and millions of voters.
Yeah.
So statistically, it's a humongous number, but maybe practically it was only like 2%, right? Or 1% different than what it was expected. But that still counts, yep, reject the null hypothesis, significant evidence, there's something going, that's different. And then you can do your confidence interval with the Iowa data and write that out. So yeah, I think that's a wonderful idea. It won't take you that long. I think the data should be readily available. Make sure you cite your source. And yeah, I think that would be perfectly awesome, and you should do very well with that.
Okay. I have like one more question about the final video. Do you want us to do like a record like our faces, or can we do like a voiceover?
Either way is fine. Yep, either way. Yep. So what I like about that is it helps you boil down. Like for instance, in 2 weeks from now, you're on your family vacation, let's say, and somebody asks you about your summer stats class, and they go, oh, you're like, oh yeah, I did a final project. Okay, what was it about? Oh, I talked about the percentage of kids that go to higher ed after high school and compared Iowa to the United States. And everybody's like, oh, wow, that's kind of interesting. Is it different, or is it the same? Is it higher? Is it lower? And then you kind of explain it. You go, well, here was the national average, here's the Iowa average. Statistically it showed, or maybe it didn't. And so you just explaining that will help you later on tell somebody else about it. Plus it tells instead of your classmates reading through your whole write-up, they can just go, watch a minute or two video and go, oh, that's a pretty cool idea, and offer their feedback and ideas and compare and contrast with what they found. And so it's Yeah, so it's up to you. You can show your face. You don't have to show your face. You can just make a PowerPoint. You could just show your Word document with all your charts and graphs and everything. And yeah, so either way is completely fine.
Okay.
Yeah, excellent. Great, great. So that's that. You're going through the normal progression. Some people ask me, hey, can you send me some example projects? I'm like, as soon as I send you a sample, I'm going to totally ruin your good idea, because it's going to bias you to think, oh, I'm just going to do that, and I'll get a million projects that are the same. I'm like, no, pick something that's of interest to you, that's with your major, something you're curious about. Start there and seeing if you can ask a question, find relevant data, analyze it, articulate that, explain it. That's going to stick with you a lot longer than I copied this other person's idea and went and did this thing. It's okay. So that's why I encourage people, go to the discussion board, look at what things people are doing, to go, oh, okay, that makes sense. Did that help you? Did you do that?
Yeah.
Okay, cool. That's the way it's supposed to work. I've had a few people texting me going, essentially kind of push me in one direction or another. I'm like, I don't really want to do that. I don't want to ruin this cool process for you. So good job coming with a cool idea, thinking about it, looking at those ideas, adjusting. Yeah, I think it's wonderful. That's the way it's supposed to go.
Then should I put this all in my discussion board, like change it up?
If you've already done the first one, preparing, don't do it again. Just start working on the final one. And if you do, and what I like to encourage, I put Friday as the deadline for the final project. The only reason I do that is just so I have time to give feedback in case, let's say you make an error. You type something wrong in StatCrunch, or use the wrong number, you didn't explain your decision correctly, or the confidence interval correctly, or use the wrong notation, or you mess something up. I'll score it, make comments, and then you can fix that if you want to improve your score. If you're fine with your score, you're good. If you want to change it, then that'll give you until Tuesday to fix it. Now, am I going to accept projects all the way up until next Tuesday? Of course I am. But that doesn't, it's just going to, they're just going to be stuck with their grade potentially, just because the turnaround time would be so quick. So does that seem reasonable?
Yeah.
Okay. So that kind of explains kind of the why I'm wanting it by this Friday. Obviously, I'm probably working over the weekend too, so I'll be grading them as they come in, and it'll, people can still do that thing. But if I don't put a date down, I'm going to get slammed with 60 projects on Monday with a 24-hour turnaround time, and it's just nobody has time to watch anybody else's presentations and give feedback, and I don't have time. So that's why I put the Friday due date on there, just to encourage, everybody who wants to have a chance to improve, that's enough time then. So, yeah. Awesome. Really good question, Emily.
All right, I'm good to go.
I think you are good to go, and I recorded that little bit. Just that explanation right there, I think will actually help quite a few people. So thank you for asking that.
All right, thank you.
All right, have an awesome day. Look forward to seeing your write-up.
Bye.
All right, great job this summer. All right, I see Sean is in here. Sean, can you hear me okay?
Yeah, I was just waiting until you guys were done.
Yeah, cool. What's your idea?
So I'm coming up with them now still. I'd like to do something psychology related.
Oh, nice.
I was just going to try to see kind of what some of your feedback might be on maybe like depression rates or something like that. So I didn't know what would be easily accessible. I've done a little bit of research, but not much. Just because my major is psychology. I wanted to do something that other people haven't done as well, and something that
I had somebody last semester look at this idea of mental illness and depression rates. Oh, hey, Kitty.
Yeah, he likes to crawl.
I think I got mine knocked out of here. So that they did it comparing, I think, college age students versus the general population. So if there's a higher rate of occurrence of certain types of mental illness. There might be, maybe you can look at it longitudinally, like for instance, in 2020, mental health, the certain type of mental health thing compared to maybe 20 years ago. Has it changed? You can look at the rate. You could look at, maybe, again, Iowa. How does Iowa compare to other states? So like you can compare different demographics, right? Maybe even based on socioeconomic status, there's a different rate of occurrence of mental illness, right? And so you can, there's lots of different ways you can size it. So like if you're most, like you said, depression, right? Like, or you can say anxiety and depression or some form of that. I think I've heard stats, like 1 in 5 Americans have been, are being treated or diagnosed for that at some level. Maybe you could compare, is that, is Iowa similar to that, or maybe age 20 to 30, is that a rate, or has it increased? One thing you could do that's maybe interesting is, you remember chapter 10, it's linear regression. Some people have done things where they like tracked it over years, right, to see the trend, to see if it's sloping up or down or whatever, is it increasing or decreasing. Seen some very cool write-ups. So like, okay, I'll take the rate in 1970, 75, 80, right? And they track those percentages and make a linear regression, put them in StatCrunch, linear regression.
One of my ideas is to do that with like the past 10 years and then include the COVID state, and then specifically like look at the COVID state and see how it affected mental health rates. Across the nation and then across the United States, and some states have dealt with COVID worse. So that was kind of my general idea, but I was looking at mainly depression because it's more of a, set category versus just a broad one of overall mental health thing.
And plus there's less stigma with that one. So your ability to measure the actual population is probably better, right? So the stigma is being lifted, like it's okay to be, because like I just saw it on the, actually I was at Iowa City, and a bunch of breweries are making, it's okay to not be okay. That's kind of the theme on it, kind of thing. And like just bring awareness to stuff. So I like that idea. So especially I like that idea, like if you could find data from measure, and so what was the rate over COVID, maybe compared to a year previous or 5 years previous, that's a good, try to compare those. Your null hypothesis would be they're equal, right? There's no difference, because and that's what we assume. Alternative is that it's greater than or less than or whatever, and then you could find some sample data. Even if you could just like maybe like Iowa then and Iowa over COVID would be a pretty cool, if you can find both. So dig around data sets. I did post on Blackboard. I'm trying to think if there's anything related to your, anyway, a few sample data set sites that people have used in the past. I put it right above the, in the week 7 in the project discussion. There's a little PDF there. I don't know if I can't remember if there's psychological stuff in there or not, but anyway, you're gonna have no problem finding good sources, I think.
Okay.
But, how does that all sound?
Quick, I'm good now. I just wanted to kind of confirm and see if you thought it'd be like a worthwhile thing pursuing. So
yeah, and like I said, so when you have huge numbers, like if there's like all Iowans, that's okay, that's millions of people, or just all adults, that's like still like a couple million people. A small change statistically will look huge, right? Like a difference between like 20% and 21%. Statistically could look really big. Now practically it's maybe not that big of a difference, right? So there's this kind of thing of statistical significance and practical significance, and I really like students that identify that. There was a statistical difference and a rejected null, and there's a difference here, or it's increased or whatever it is, but practically it may not make a huge difference in the big picture. When you go tell all your friends, did you know that depression rates went from 20 to 21% over COVID? They'll be like, okay. But that's a huge statistical, they're going to be like, okay, it doesn't seem like a huge increase to me. Does that kind of make sense?
Yeah, that all makes sense.
Yeah. But just being aware of that, I think, is really an important thing. But no, that's a great idea, especially it's in your major. If you are going to pursue psychology, like through a master's degree, are you thinking?
Right now, I'm doing my bachelor's at Iowa State. I start next semester. This is the last class I need to graduate from TMAC.
Okay.
After I graduate this, I already have my registered classes for Iowa State, and then I might get a master's. I'm not sure yet. Just depends on. Sorry, my cat's going crazy next to me. Yeah, so yeah, I'll probably get a master's.
Yeah, so typically, if you're going to psychology at some level, you will get your master's. You don't have to be a researcher per se in psychology, but you will be expected to be able to read and analyze a lot of research, and you're essentially applying a lot of that to, if you're even in therapy or psychiatric, or social work, whatever it is. And if you do go to graduate school, like this course is a good thing to prepare you actually for that graduate level stats class that you might take at some point. I've had people take this class to prepare for that, 400 level general graduate level statistics class, because everybody pretty much, that's master's level PhD, they always have a bent towards research. Well, how do we analyze data in research? You have to have statistical methods and statistical thinking. So this is a good way for you to start going down that path. There's a colleague of mine at DMAC. She was a clinical psychologist, right? She did a lot of research in child psychology, and that's the thing. I've talked to her many times, and she's like, when I see psychology majors who don't want to think statistically, I'm always like, well, that's kind of going to be the thing you have to do all the time, right? You don't have to perform your own research, but you're going to be given research about, here's a treatment that's been done. Here has been the change in these things, and here's the p-value for that. And here's how do you analyze that, and what's the potential errors here? What's the lurking variables? What are the biases? Is this warrant further study? Did we control enough variables? All of that kind of thinking is just super important for people. Anyway,
there's a ton of overlap in it. I've already seen that from writing papers and stuff like that. Pretty much all papers I do in English class and stuff are over psychology, just out of interest. And there's almost a huge overlap in just analyzing the data and saying whether it's a significant impact on, the societal outcome of a certain medicine or whatever it is. So, yeah,
very
I already
cool.
see that.
Yep.
And I like that.
That's awesome.
Because math is a big interest for me. So,
well, I would say you'll be very successful then, because not every psychology major has that kind of like, oh yeah, I like this makes sense, I see how the importance of it, I can apply it and think this way. That will separate you from the pack, let's put it that way. And that's awesome. So I'm really glad you took this class this summer.